Hello everyone. Our today's topic for the A-level chemistry 9701 AS level is chapter number 7, redox reaction. What are the redox reactions? First of all, we have already learned about oxidation and reduction, but here in this chapter we will discuss oxidation and reduction with respect to gain or loss of electron only. Oxidation is loss of electron, mean OIL, oil, and reduction is the gain of electron, mean RIG, oil rig. This simple two words or making one words can be used quite easily to remember the definition of both oxidation and reduction. More briefly, I can say redox reactions are those in which one or more element is taking part as a reactant. One or more elements are taking part as a reactant. Those all reactions are called as redox reaction. Example, we can give example of this as, for example, if magnesium is reacted with hydrochloric acid, if we balance this equation, what will form? It will form magnesium chloride and hydrogen. Here, in this case, this magnesium is metal, while HCl is a compound. As one of the reactant is element, that's why this reaction will be automatically a redox reaction. Why? Because according to the definition, according to the rules, we already have learned that whenever the oxidation state of certain elements change, then definitely that reactions are called as redox reaction. Now, in this reaction, on the basis of the previous knowledge, we can say that here in HCl, this is minus and this is plus. The oxidation state of hydrogen in this compound is +1, but here the oxidation state of hydrogen is 0. It means that oxidation state is decreasing, mean reduction is taking place. If reduction is taking place, then definitely this will be called as the oxidizing agent. And the oxidation state of magnesium is 0, and this is becoming +2. It means that oxidation is taking place of magnesium, means that magnesium is acting as an reducing agent. So, whenever, according to the definition, whenever in a chemical reaction their reactants contain one or more element, those reactions will be automatically redox reactions. Now, how we balance the half ionic equation? For example, this is the equation. We have to balance this two half equations. We have to just balance the electron gained or lost. In the first equation, the electrons are lost. It means that oxidation is taking place. But in second equation, electrons are gained. It means that reduction is taking place. Now, we have to just balance the electron gained or lost. If we want to balance, first equation will be multiplied by 5, and the second equation we can multiply by 2. Why? Because on multiplying 2 by 5, automatically electron will become 10. And these 5 electrons on multiplying by 2 will automatically become 10. It means that number of electrons gained or lost will become equalized, and then whole of the equation on addition will give us a balanced chemical equation. I can write here, for example, if I multiply this equation by 5, it means that 10 iodine gives 5 iodine molecules and then 10 electrons. Now on multiplying the second equation, 2MnO4 minus plus 16H positive and plus 10 electrons gives 2 Mn positive 2 and then 8 water molecule. We have to add both of these. The number of electrons lost are cancelled by the number of electrons gained. What is the overall equation? The overall equation will becomes 2MnO4 minus plus 10I negative plus 16H positive. This will gives us 2Mn positive 2 plus 5I2 and plus 8 water molecule. Now if we look at this equation, this is already balanced. 2Mn, 2Mn. Then 8 oxygen, 8 oxygen, 16 hydrogen, 16 hydrogen, 10 iodine, 10 iodine. It means the total charges minus 2, minus 10, minus 12, minus 12 plus 16 means overall answer will become plus 4. And what is here? Plus 4. Charges are also balanced. The charges are also balanced. In this manner, the half equation can easily be balanced out. Now, we move towards the oxidation numbers. Oxidation numbers. Oxidation number. Oxidation numbers. What are the different rules? Number 1. Oxidation state of atom or molecule is taken as 0. Second, oxidation state of hydrogen is taken as +1 except in metal hydride where it is -1. Third, oxidation state of group 1, 2 and 3A is +1, +2 and +3 respectively. Fourth, oxidation state of oxygen. Oxygen is taken as -2 except in per and superoxides where it is -1 and -1/2 respectively. Next is fifth, sum of oxidation state of all atoms in a compound is 0. Then sum of oxidation state of all atoms present in ion is equal to the charge present on ion. These are the basic rules. Using these rules, we can easily find out the oxidation state of any element present in the compound. As we have learned that group 1, group 2, group 3A elements have oxidation state +1, +2, +3. These are the fixed oxidation states. These will never change. The oxidation states start changing from 4th group elements to the 7th group element, even till 8th group element. Now, using all these rules, we can find out the oxidation states of elements of group 4, 5 or 6. For example, if we have to find out the oxidation state of sulfur in sulfuric acid, according to the rule, as 2 hydrogen is there, the oxidation state is multiplied by number of atoms present. Oxidation state is +1 multiplied by 2. Then oxidation state of sulfur is, we have to calculate, multiply by 1. Number of atoms is 1. Similarly, plus, this is a normal oxygen compound, that's why oxidation state of oxygen is -2 multiplied by 4 is equal to 0. Because the overall charge on this compound is 0. If we calculate all these, then we will find out +2 plus 1s and then -8 is equal to 0. If we solve this, we will find out s minus 6 is equal to 0. If we shift this -6, this will become +6. It means that the oxidation state of sulfur in the sulfuric acid is +6. Similarly, if we have to find out the oxidation state of, for example, KMnO4, it means that this is the first group element +1 oxidation state is multiplied by 1 plus Mn multiplied by 1 plus -2 multiplied by 4 is equal to 0, because the overall oxidation state is 0. Now we can calculate this easily. +1 n plus Mn and -8 is equal to 0. By solving this, we will get Mn -7 is equal to 0. And by shifting -7, we comes to know that oxidation state of manganese in KMnO4 is +7. Now, if we take an ion just like Cr2O7 -2, we have to find out the oxidation state of chromium ion. Here, chromium Cr multiplied by 2 plus -2 oxygen multiplied by 7, total number of oxygen 7, is equal to -2, because the charge present on ion is -2. So when we will calculate this, this will show us that 2 chromium -14 is equal to -2. By shifting this 14 there, we get 2 chromium is equal to -2 and plus 14. What will be the answer? 2 chromium will equal to 12 plus 12. 1 chromium will definitely have plus 6. It means that the oxidation state of chromium in this ion is plus 6. This is the method how we find out the oxidation state of any substance which we are asked for. Similarly, for the example, there are so many. For example, calculate the oxidation state of chlorine Cl2O -1. Definitely, this is chlorine. How many atoms? 1 plus. Oxygen has -2, and how many? 2 atoms are there is equal to -1. Now we can calculate this easily. Chlorine -4 is equal to -1. By shifting -4, we will get -1 plus 4. Answer will become automatically plus 3. It means that the oxidation state of chlorine here in this compound is -3. In this manner, we can easily calculate the oxidation state or oxidation number of any element present in a compound. Now, this will guide us quite easily. This will be helpful in balancing the equation which we will balance with the help of the oxidation number. Now, how we can name the different compounds? This is our formula of chloride, oxychlorides. If by balancing this -1, I can write here, for example, sodium NaClO2. NaClO2. Now, how I will mention the name of this compound? I will write this compound sodium oxychloride. Sodium oxychloride, mentioning its oxidation state 3. Mentioning oxidation state 3. Whenever we have to mention the different compounds, similarly, if I have this formula, I will first find out what is the oxidation state of sulfur. Here the oxidation state of sulfur is, this is +2, this is -6, automatically this will become +4. This is the oxidation state of sulfur. Now, I will mention the name of this. Sulfur acid. Sulfur 4 acid. Acid means sulfuric acid or sulfurous acid. Sometime in the previous language we were discussing as a satanic or satanus, plumbus or plumbic, or sometime we use so many different naming technique, but now we have to mention the compounds with the oxidation state of the central atom. This is called as a systematic nomenclature scheme. I thank you all.